is on the target. No, no. Till the battle's won, till kingdom come. I'll never run. Best to give me your loyalty, 'cause I'm taking the world, you'll see. They'll be calling me, they'll be calling me royalty. Best to give me your loyalty, 'cause I'm taking the world, you'll see. They'll be calling me, they'll be calling me royalty. They say I'm dangerous 'cause I broke all their cages. No, I won't sit and take it. No, no. They left me for dead, I guess I'll never learn. Every time I break, there's just more pain to burn. They'll never, never, never learn. Till the battle's won, till kingdom come. I'll never run. Best to give me your loyalty, 'cause I'm taking the world, you'll see. They'll be calling me, they'll be calling me royalty. Best to give me your loyalty, 'cause I'm taking the world, you'll see. They'll be calling me, they'll be calling me royalty. Even now, you're coming up to me, fire lighting up the sky. Feel the ground shaking underneath, trying to take me alive. Get ready for the fallout. Can't stop me now. I got no rival. I'ma find my way through the blood and pain game of survival. Any time or place, watch 'em run away. I got none. I'll be standing on my own, never gonna take my throne. I got no rival. Watch 'em run away. I got no, no, no. I got no, no, no rival. No rival. No rival. wait for something to let it go to waste, with everything at stake. Not that I would take it all back, I just wanna make this thing last, but we're running out of time. We were doing alright, holding on, but I'm losing the fight. Could we run away? I know if we just hit ground, running, closing off all the world with the light coming in.
Good night, everybody. Attention for the judge. How is everyone? Yes, Ismail. 500 subs. We day. On the road to 1,000. 1,000 subs and 4,000 watch hours. That is the goal. That is the goal for the end of the year, guys. Let's see if we can reach there. Feel free to share the video, share the live. We're gonna load up. Gain them pressure tonight. Good night, all. Good night, everybody. Yes, Gerard, the road to 1,000. The big 10 to the power 3. Everything's 4 by. Well, I should be able to look up the first part of this, because the first part we're going to do tonight is strictly calculus. We're going to do we're going to do regular differentiation, transitioning into the chain rule, transitioning into the product and quotient rule, applications of calculus. I'm not going in depth, I just touching the surface. But the necessary things you all need to know. After we do applications of differentiation, we will be diving into kinematics. Now, kinematics requires a little knowledge on integration as well. So I'll just do the basics for integration in order to do the kinematics. Tomorrow we can probably dive into integration, probability and statistics, and something else. APs and GPs. That was another popular one. So tomorrow night is stats and probs, integration, APs and GPs. APs and GPs is lick up thing. Real lick up thing. Alright. I'm gonna load this up here. Bam. Alright, so what are down? Alright. That could go one side. Alright. Alright, that could go one side, that could go one side. Come on from here. Alright, so let me talk a little bit first about calculus and differentiation. We use differentiation for plenty of things, mainly for calculating maximum and minimum points in maths. When we differentiate something, we get something called the gradient function, which we can use to calculate the gradient of a curve at any point at all. So let me see what we can do tonight. Knowledge on indices, powerful, extremely powerful, especially the law that allows you to move from a power from numerator to denominator and denominator to numerator. That law real important. So we just do a quick little thing on the law in order to differentiate. So there we go. Cool. I could probably I'm gonna fix this a little bit here. Crocodile. Cool. So calculus. Now generally, if we have y is equal to ax to the power of n, where a and n are numbers. I'll decide if I'm doing past. Yeah, we'll do some basketball questions. Sorry. Y is equal to ax to the n, where a and n are numbers. Then dy dx is an x to the n minus 1. So in basic Chopperman terms, you're multiplying by the power and we're dividing by the power. It's important to know the variables. So this is y in terms of x. So that is why we have dy dx. If I have theta is equal to a alpha to the power of n, then instead of dy dx, I'll have d theta d alpha is a n alpha to the n minus 1. So it's important to know what variables we are given in the question in order to know what the differential is going to be. So simple examples. If I have y is equal to 2x to the power of 3, dy dx, again in the Chopperman terms, multiply by the power, 3 2 are 6, x, and minus 1 from the power. 3 minus 1 is 2. Real easy. Y is equal to 4x to the minus 2. Again, dy dx means multiply by the power. 4y minus 2 is minus 8. X minus 1 from the power. Minus 2 minus 1 is minus 3. Now, some special cases, and we'll just browse through the special cases here. If I have y is equal to 6. Here we go 6x first. This x has a 1 attached to it, but we just don't write it down. In fact, all numbers and all variables, let's say x, it's raised to the power 1. It's multiplied by 1 and it's divided by 1. But we just don't write in those things there. Right? But because it's understood. So, dy dx, I multiply by the power. I'll just put in the 1 there. 6 by 1 is 6. X to the 1 minus 1 is 0. Laws of Indices says anything to the power 0 has a value of 1. So this is equal to 6. Remember, the x to the power 0 will have the value of 1 because the 0 is on the x. This whole thing is not 1. Alright? Just the x to the power 0 is 1. So I get 6 multiplied by 1. And this is a pattern. If I just have a single variable with no power, well, no visible power attached to it, or anything to the power of 1, then the differential, the first differential, is just the coefficient. The next special case is if I have something with no variable. Well, dy dx is equal to 0. Just to go through a quick proof of it, it does have a variable there. It's x to the power 0. 0 by 2 is 0, and 0 by anything is 0. But in Chopperman terms, just for you to remember it, the differential of a constant is 0. The differential of a variable to the power of 1 is just the coefficient. Now, the trick to move things from top to bottom and bottom to top is important. Your trick to change square roots and stuff into powers is also important. So let me go with the moving it up and down first. Y is equal to 4 over x cubed. Generally, whenever you're differentiating, I want you all to focus on one important thing. The variable is always on the numerator. Look at the first set of examples. All of the variables are on the numerator. And all of the variables are raised to a power. That is why we could have used these laws up here. Y is equal to ax to the n. The law to multiply by the power and take away 1 from the power. So all of the differentials you will be executing needs to have a variable on the numerator and it must be raised to a power. But among this variable not on the numerator. Means problems. We're in some technical difficulties. So what do? We bring the variable on top and apply the law of indices. Whenever I move a variable from denominator to numerator, the power changes. from positive to negative or from negative to positive. So this will be, shucks, y is equal to 4x. I bring the power on top. I bring the variable on top. So the power changes from positive 3 to negative 3. Now I can differentiate. dy dx is minus 12x to the minus 4. The question gave me the variable with a positive power and the variable was on the denominator. Well, I'll try to give back the question in that form. Minus 12. Now I'm going to move this to the denominator. So I'll have to change the power to positive. Next example. 12 over, let me do 12. Let me do 9 over 2x to the power of 4. Now, some might move the 2 on top and the x to the power 4 on top. Your job is to move only the variable. Only the variable. So I'll move only the x to the power 4 on top. So y is equal to 9x to the minus 4 because that's the only thing that moved over 2. I have a couple ways you could attack this. The easiest way without any big set of confusion, just differentiate this as normal. Brother man, dy dx is equal to 9 by negative 4 is minus 36 x to the power of minus 5 over 2. Give me 1 second, guys. Yeah, fellas. So got that? Alright, there you go. Now the question gave me it a particular way, so I'll give them back in a particular way as well. Now you can do this, bam bam, minus 18. So minus 18, and I'm moving the x to the minus 5 to the bottom. The power just changes to positive, x to the power 5. Now, before I even do the solution, give it a try now. Y is equal to 7 over 3x to the power of 3. Well, homeboy here had to go on top. So I get 7x to the minus 3 over 3. Differentiate dy dx minus 21 x to the minus 4 over 3. I could go and hit them the division here. Minus 7. This is equal to minus 7 over x to the 4. Another way I could tackle these type of integration questions, differentiation questions, I'll do back this example here. So I'm gonna parallel or move you around a little bit, and let me see how another way we can tackle the questions. This way could be a little easier for some. It could not be a little easier for others. Another way I can write 9x to the minus 4 over 2 is 9 over 2 x to the minus 4. Now this here becomes my a. Like this here is my 4. This here is my 6, is my 12, is my 2, and so on. So I'll multiply by the power dy dx 9 over 2 multiplied by 4. Nothing wrong if you use a calculator to do this. It has zero shame using a calculator to do this. right? Please don't feel embarrassed to use a calculator to do a simple multiplication like this. I myself just double check simple things, nothing wrong with that. 9 over 2 multiplied by negative 4 is minus 18. So this here is minus 18 x to the minus 5. And I just move the x on the denominator. X to the 5. Either or is fine. In my opinion, the black working is the easier way to do questions like this. The next case for differentiation is when you have roots as powers. Now, generally, I'll just review the law of indices. The law of indices, when it comes to roots, changing a root to a power, the denominator on the power tells the root of the number of the base, and the numerator tells the power inside of the root. So for example, this is a review on our little indices. If I have a to the power of x over y, this denominator tells me the root. Now, I wouldn't write it down. I'll just go back in some of my notes here. So let me use all the notes there is my differentiation. No, not differentiation. Logs, indices, yes. Right. When I have a 2 on the outside of a root is the square root, which is basically understood. When I have a 3 outside of the root is the cube root. When I have a 4 outside of the root is the 4th root, the 5th root, the 6th root, the 7th root, the 8th root, and so on. So, in these questions here, the root will be the white root. So it's the white root of a to the power of x. Now let me put some numbers to the test here. 4 to the power of 9 over 3. This is equal to, as soon as I have a fraction as the power, I know some root business going on. The denominator will tell me the root. So this tells me it's the cube root of the base, which is 4. And the numerator tells me the power. Now it works vice versa. And the vice versa is what you need to know real good for differentiation. So let me do one more example. If I have 13 to the power of 2 over 7, this is the 7th root of 13 squared. Yes, the live will be saved afterwards, so you can go and watch it afterwards, JD. Now let me try and go from root back to indice form. If I have the 4th root of x to the power of 11, the base will be x, the power inside the base will be the numerator, and the root will be the denominator. Let me say we have the 5th root of 237. 2 is the base. I have a fraction here. 5 is the denominator. And 7 is the numerator. So let me try some differentiation using these roots back now. So for example, let me say I have y is equal to the square root of x to the power of 5. I'm going to put that power 5 a little better. X to the power 5. As it stands, I have a root. I want to change that to a base to a power. So y is equal to x to the power of the 5 will be my numerator and the 2 will be my denominator. Well, the law says add and multiply by the power. This is a 1 that is understood in front of here. So 1 by 5 over 2 is 5 over 2 x. And like I said, nothing wrong with using this. 5 over 2, take away 1, 3 over 2. Now, be careful. Be very, very careful. when you are changing it back, and I recommend you change it back. This here, I want you all to focus on what I'm saying. When you're playing with indices and you're executing, moving something from top to bottom, or changing something to a root, or putting something in the form of a root, I want you all to identify one very, very crucial thing. Identify the base that's attached to that power. And that's the only base that you will execute the laws on. Nothing else. For example, here, the power is just on the x. I've seen this happen already. Please avoid it from happening. I've seen people say, well, you know, this could be the square root and this could be the power inside the root, which is to the power of 3. I've seen people do this. The square root of 5 over 2x cubed. Please refrain from doing that. That 5 over 2 don't have no power, no fractional power attached to it. So homeboy staying by himself. Homeboy staying by himself. So he remains as 5 over 2. The x has the fraction on it. So the x will be the square root of x cubed. Easy peasy. Please don't make that mistake. Please, please, please don't make that mistake. I'll extend that mistake to this example. Y is equal to, oh shucks, there's dy dx, dy dx. Y is equal to 4 over just the square root of 2x. Now, 2x has the square root over it. So that will be my whole base I'm talking about there. So this here will be y is equal to 4 over, it wouldn't be this. It will not be this. 2x to the power of 1 over 2. No. This telling me that the x alone will have the square root attached to it. But in reality, the 2x has the square root attached to it. Now, something like this might come because I don't think CXC just bring things so difficult. So I just want to show you all the bare essentials. So I'll work with the x. This becomes 4 over x to the half. This is 4x to the minus a half. Minus a half by 4 is minus 2. X minus a half minus 1 is minus 3 over 2. Another important thing, guys. Do not use decimals or mixed numbers when you're performing differentiation procedures. Leave it as improper fractions only. Please, leave it as improper fractions only. So this is minus 2 over x to the power of 3 over 2. And now I can change this. There's dy dx. dy dx. dy dx. dy dx. And dy dx. I'll change it to the square root of x cubed. Alright? Well, what had I teach earlier? Oh, no. They wouldn't bring something like that. I have seen on any past papers with respect to that. I think Monday night I'll go through past paper questions, okay? Because it's only paper 2 we have to go through. So we go through past paper questions, and then from Tuesday we go start looking up paper 1 every night. Alright. Let me try to combine some good. Let me try to combine some calculus procedures here, where we have a whole set of stuff mixed up in one differentiation question. Example, y is equal to, an easy one that we learn, 4x squared plus a little complicated one, 3 over 7x cubed minus the fourth root of x to the power 3 plus 6 plus 2 over the cube root of x squared. Give it a try. Give it a valiant effort. I write here, I as a man given only about 2 minutes. 2 minutes to do it, and then I go in and do the solutions. In the meantime, interact with me in the chat, so we don't just be silent going through these things here. I just interact with me in the chat, making sure everything good. Make sure and share the video and stuff with all your friends and family. Send it to your cousin, your auntie, and then everybody. Now, after this, we go in and go through some we're going to go through some other rules where it doesn't really play by, it doesn't come so simple. All right. So I'm gonna actually do it at, I could probably put in the clock here and there, man. Right, so I will use that clock as a little reference point there. All right, so I had enough time. Let me tackle it. First things first, I do not have everything that looking like ax to the power of n. So I'm gonna try and bring everything to ax to the n. This term here, the second term here, I need to change it. He needs to change and he needs to change. So let me take it step by step. So y is equal to the first term, good. I could differentiate him, plus I just moving the x cube on top, 3x cubed over 7 minus, this is the fourth root here, guys, the fourth root, x to the power of 3 over 4 plus 6 plus 2 over x to the power of 2 over 3. One thing still giving me a little problem here, the x to the power 2/3, so I send homeboy upstairs. Y is 4x squared plus 3x cubed over 7 minus x to the power 3 over 4 plus 6 plus 2x to the minus 2 over 3. And now we start to differentiate. dy dx is equal to 8x to the power of 1 plus 9x squared over 7. Oh shucks, there's minus 3. Sorry. Minus 3. So this is going to be plus minus 9 to the minus 4 over 7 minus 3/4 x to the power, and I could go on my calculator, 3 over 4 take away 1 is minus 1/4. The differential of any constant is 0 plus minus 2/3 multiplied by 2. I will do it here. Minus 1 1/3 or minus 4 over 3 plus negative 4 over 3 x and minus 2/3 minus 1. I change it to improper fraction, minus 5 over 3. That's my power. Now it's time to fix up a little bit. dy dx. Any questions? Because I'm moving on after this. 8x minus 9 over 7 x to the power 4 minus 3 over 4 x to the power of a quarter plus 0 minus 4 over 3 x to the power of 5 over 3. I move these things around one time. Now it's just to change the powers to roots. 8x minus 9 over 7x to the power 4 minus 3 over 4, the fourth root of x, minus 4 over 3, the cube root of x to the power of 5. My bad. Use the 4 as the 4, not fourth root. That is okay. It does look like that. But in the paper, yeah, they wouldn't visually. They'll make it visually easy for you all to see it. Any questions before I move on? I'm going on to the chain rule now. So I'll give you a little 9:15 to ask my question regarding this, and then we're moving on to the chain rule. I'm waiting. I'm trying to say he Gucci. Alright, so Amjad say good. Now, if you all have a question, feel free to voice them in the comments, either in the live comments, or if you're watching over the video, voice them in the comments below. Alright? I need to know. Because I mean, at the end of the day, I want all pass, eh? I want everybody pass us. Like big man thing, I want everybody to pass. So that is why I'm doing this. I'm doing this for you. Alright. We jump out. We're going on to the chain rule. Now, when you see something to differentiate like these fellas here, off the bat, they take the form ax to the power of n. So we use this law that we learned in the beginning to differentiate it. But in the chain rule, things does not look like ax to the power of n. Things look like some function of x. I put f of x, some function of x raised to the power of n. And this function of x, it have more than one term inside of it. For example, y is equal to 4x plus 2 to the power of 6. I will differentiate all of these after. Y is equal to 6x squared minus 3x to the power of 11. There could be more than two terms inside of there. 2x plus 4x squared minus 3 to the power of minus 16. At the end of the day, whenever you see something that looks like a function of x raised to a power, you can use the chain rule. Now the chain rule is also called the substitution rule, and we have to make a substitution. If I show you one, I show you all. Same conditions apply with respect to the function being on the denominator. If it's on the denominator, the whole thing had to come up on top. For example, in this one here, if I have 4 over x plus 1 all squared, I need to differentiate this, but this function of x here needs to go on top. Now, the first thing we do is let t be whatever inside of the brackets. Now, the first thing. Let t be, in this case, 4x plus 2. Then we differentiate that line that we now write down. Remember, in the beginning, in this example, I had theta in terms of alpha. Over here, I had y in terms of x. Down here, I have t in terms of x. So when I differentiate it, I'll have to write dt dx. Differentiate it as normal, and I get 4. Next, I'll say, since t is 4x plus 2, look at y. Y now becomes t to the power of 6. Because this here, I let that be 4x plus 2. I let that be t. And then I differentiate that. I have y in terms of t, so dy dt is 6t to the power of 5. Finally, I go in and write down dy dx. And there's a formula from now until forever. Now, some teachers use u as the substitution instead of t. That's all well and fine. Dy dx is going to be dy dt multiplied by dt dx. And please put the chain rule in brackets because that's what we're using. Dy dt by dt dx. Dy dt is this. Skip a line. 6t to the power 5 multiplied by dt dx is this. 4. I can multiply the numbers. I get 24 t to the 5. Replace what t is. 24 open bracket 4x plus 2 to the power of 5. And that's it. Like I said, I'll show you one, I'll show you all. Some of you all will know the shortcut to it. I will strongly suggest and I recommend, if you get a chain rule, just a chain rule alone, use the chain rule. Don't use the shortcut. If you have a product or a quotient rule, and inside of the product or quotient rule, you have a chain rule, then use the shortcut. Please. Let me do the next one. Well, my first step in green says, let t be whatever in the brackets. And I'll differentiate that. 12x minus 3. Next, y becomes t to the 11. I'll differentiate that. 11t to the 10. Next, I write down dy dx. It will be dy dt multiplied by dt dx. And this is the chain rule. Dy dt is 11t to the 10 by dt dx. Dt dx is 12x minus 3. Be careful. So put that in our bracket. This is 11. T was 6x squared minus 3x to the power 10 multiplied by 12x minus 3. Don't bother to expand. Don't bother to simplify. Leave it like this. Leave it like this. Let's attempt the third one now. If anybody have any questions, shoot them. Alright, let t be whatever in the bracket. 2x plus 4x squared minus 3. Differentiate it. 2 plus 8x minus 3 turns to 0 when I differentiate. So therefore, y becomes t to the minus 16. And I differentiate that. Minus 16t to the minus 17. Remember, we're taking away 1 from the power. So minus 16 minus 1 is minus 17. Next, we write down the chain rule. dy dx is dy dt by dt dx. And this is the chain. dy dt is minus 16t to the minus 17. And the t dx was 2 plus 8x. Replace what t is. T is 2x plus 4x squared minus 3 multiplied to the minus 17 multiplied by 2 plus 8x. Now, this is a good example where we isolating the term that has the power that we're executing our law on. This is the only thing that has a negative power on it. Now, I did remember saying, I did say, if the question gives it a particular way, give the answer in that particular way. But I just go in a step further just to show you all how we're dealing with this negative power here when you have more than one term inside of the expression. That is the only thing that has the negative power attached to it. So that's the only thing I'm moving. The minus 16 remains. The 2 plus 8x remains. And the only thing that moves is 2x plus 4x squared minus 3. And the power becomes positive. Now, that is it for chain rule, guys. I will show you all the shortcut. If anybody has any questions on the chain rule, I need to know now. I need to know before I finish this next example. I need to know. If you all understand, say you understand. Give me some form of feedback as to what we did in the chain. In this one here, I have the whole expression on the denominator. So I need to bring the whole expression on top onto the numerator. And we use the laws of indices. The whole thing is going on top. So the 4 not moving, but the x plus 1 is moving. And that becomes to the power minus 2. We'll let t be the brackets. And we differentiate it. 1. When t is the bracket, y is 4t to the minus 2. And we differentiate. Minus 8t to the minus 3. And then we write down the chain. Y dx is the y dt by dt dx. And homeboy is the chain. The y dt is minus 8t to the minus 3. And the t dx is 1. This is minus 8t, which is x plus 1 to the minus 3. And just move the x plus 1 to the minus 3 onto the denominator. X plus 1 and the power goes to 3. And that is it in a nutshell for the chain. Same procedure over and over and over again. Any questions? Your boy needs to know. I need to know, man. I say good to go so far. Ronaldo, you're late. Hey, Reese boy, what up, man? Alright, so I'm guessing everybody good so far, right? I'm just making sure. Alright, let me go on to the product rule. Now, similar to the chain rule, the product rule requires a little bit of substitutions as well. And you have the visual cues to see if you're using the product rule or not. I think I will end the stream when I finish probably differentiating strings. We wouldn't have time to do the kinematics tonight. I need my beauty sleep. So we have the quotient rule here. Sorry, product rule. Now, the product rule is used whenever we have a function of x multiplied by another function of x. So it looks like this. F of x by g of x. And I write down some examples. Y is equal to x plus 2 into x plus 3. Yes, you could expand it. Yes, you can expand it. But you can also use the product rule to differentiate this. And you'll see the power of the product rule when we have something like this. 2x minus 1 squared into 3x plus 2 cubed. It could be expanded, but it takes a while. I'll just do 3 examples because all 3 examples will require the same type of working. Think they'll sneak in logs into section 1. Yeah, we will do logs. Logs is one of those topics that does really give students a lot of pressure. So tomorrow night we go do logs. Well, tomorrow I want to focus on the afternoon to do work. Alright? A little after lunch and thing, huh? Y is equal to x plus, there we put 6x plus 1 to the minus 4 into 3x plus 12. Now, I'm going to show all the shortcut to the chain rule here. All these things on top was the chain. I'm just going to do the shortcut for the first 2 because it's the same thing over and over and over again. And it's easy to show for the first. 4x plus 2 to the power of 6. First thing I want you to do, treat that whole bracket as 1, 2. Let me pretend we imagining it's A. So in my imagination, this is what's going on. There's my imagination on the side here. Y is equal to A to the power of 6. And go ahead and differentiate this. When I differentiate it, I get dy, it will be dy dA is 6A to the 5. So that's the first thing I want you to do. Pretend that the bracket is one single variable. So I'm doing that on this side. I'm pretending my brackets is a variable. 6 into 4x plus 2 to the power of 5. Next, differentiate the bracket alone. Multiply it. So I'll multiply by the differential of the bracket alone. The differential of the bracket is 4. I can multiply 6 by the 4. I get 24 into 4x plus 2 to the power of 5. 24 into 4x plus 2 to the power of 5. Let's do the next one. 6x squared to the next one. So again, we go in and use the imagination. Pretend that the brackets is one term and are differentiating. dy dx could be 11 into 6x squared minus 3x to the power 10. And then I'll multiply by the differential of the bracket. which is 12x minus 3. 11 into 6x squared minus 3 to the power 10 multiplied by 12x minus 3. Now the shortcut, it can indeed be executed in one line. Now, although it could be executed in one line, that doesn't mean we're going to do it all of the time. Please don't do it all of the time. Only use the shortcut when we have it in a product or a quotient, like in example 2 and example 3. Read this. Now, when you have a product rule, I want everybody who watching this live, whether you're watching it live or whether you're watching the recording afterwards, write down this statement. Is of the form y is equal to u v, where u go be my first bracket and I'm differentiating that. When I'm differentiating it, I have u in terms of x, so it will be du dx, and that is 1. And v is my second bracket, x plus 3. And the v dx will also be 1. The y dx, from now until forever, this is my product rule. It's v multiplied by du dx plus u multiplied by dv dx. And I put in bracket product rule. Now, it's easy to remember the product rule, and I will always influence students to put v first. And an easy way to remember which letter comes first is just remember your alphabet. In your alphabet, we have T, U, V. U comes before V in the alphabet, but in my product rule, V comes before U. That's how I remember it. Time to put in some substitutions now. V was x plus 3. Du dx was 1. U was x plus 2. Dv dx was 1. I get x plus 3 plus x plus 2. And this is 2x plus 5. And that is dy dx. Rinse and repeat. Is of the form y is equal to uv, where u is my first bracket, 2x minus 1 squared. This is a chain rule. I can use the shortcut. Du dx is equal to, treat the bracket as one term, and then multiply by the differential of the brackets, which is 2. And this becomes 4 into 2x minus 1. And you can even expand it out, 8x minus 4, if you wanted to. Not all the time it does work out so nice. And v is the next bracket, which is 3x plus 2 cubed. You could use the shortcut here. I'm treating the bracket as one term, 3 into 3x plus 2. Take away 1 from the power, and then multiply by the differential of the brackets, which is 3. And this becomes 9 into 3x plus 2 squared. Now, the past papers wouldn't come harder than these 3 examples at all. Next, we write down the product rule. Dy dx is equal to, I wonder what comes first, boy. Let me remember my alphabet. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, then V, but in the product rule, V comes first. V and du dx, it's a plus. U, then dv dx. And I'm putting in brackets, this is my product rule. V was 3x plus 2 cubed du dx was 8x minus 4 plus u 2x minus 1 squared by dv dx, which is 9 into 3x plus 2 all squared. Now, a question is going to ask us, express your answer in its simplest form. This is not the simplest form for this answer. I could factorize this. If you just catch your skin, don't bother to do it. Lose that 1 mark. Alright? Because the factorization process, it takes a little while acquiring the skills to seeing it like that. So if you just catch your skin, don't fight up yourself. I'm going to factorize it here. I see 3x plus 2 squared in both terms. 3x plus 2 squared into 3x plus 2 into 8x minus 4 plus 2x minus 1 squared multiplied by 9. Leave it so. Now, yes, for those who see in it, there is a 2x minus 1 here. If you express it like this, you will get away with this. You will get away with this. Okay? Lastly, let's have our next bacchanal question here. This is always come up over is of the form y is equal to uv, where u is equal to 6x plus 1 to the power minus 4. And du dx, treat the brackets as one variable, minus 4, 6x plus 1 to the minus 5. Leave it like that. Oh, and then multiply by the differential of the brackets, which is 6. Now we get minus 24 into 6x plus 1 to the minus 5. And v is 3x plus 12, and dv dx is equal to 3. A question like this could come for your exam, because this is a pretty easy one. This requires you to use one chain rule inside of a product rule. Question 2, you had 2 chain rules inside the product rule. Question 1, too easy to come. Now, before I finish the question, again, give me some feedback on the product rule. V du dx plus u dv dx. This is the product rule. V du dx. Now be careful with du dx. Minus 24 into 6x plus 1 to the power minus 5 plus u 6x plus 1 to the minus 4 by dv dx, which is 3. Now I could factorize 6x plus 1 to the minus 4 into 24 3x plus 2 into 6x plus 1 to the minus 1 plus 3. Again, if you're unfamiliar factorizing, leave it out. Alright, just leave it out. Alright? Ismail, you shouldn't have nothing to worry about. You still in Form 4. By the time I finish with all your lessons, these things you could see it before you even finish the question. Alright? It just takes practice. Alright, so you can leave this like this here if you want. If you want to change the powers to positive. I'll just do that step for you guys here. This is the only thing that has a negative, and this is the only thing that has a negative. But because they are negatives in two different parts of a multiplication or a product, I'll put the first part by itself. This is 1 over 6x plus 1 to the minus 4. Oh yeah, it's minus 24 inside. 6x plus 1 to the minus, open bracket, minus 24 into 3x plus 2. This becomes positive 4 here, sorry. Over 6x plus 1, then plus 3. Again, if you're the sketch skin, do better. Alright, so Ismail, I fixed it. Josiah, yes, you could. Nothing is wrong because addition is commutative. Yes, you could. But the reason I just try to put in V first is because of the quotient rule. I rather you learn one thing. Is literally one thing to learn, and it's just a plus or minus that separates product and quotient. All right. So tell my guys, questions. I listen. Talk to me. Hello, Gucci. Gucci gang gang. Man, who's your lips in my boy? Alright, I've seen people have no problem so far. Okay, so next I'm going to do same thing with the quotient rule. 3 examples on the quotient rule. Then I will differentiate trigs. I'll differentiate trigs and we'll call it a night. I will probably, when I finish, I'll do some kinematics afterwards. Not tonight. On my own, I'm talking about. I'll do some kinematics and upload that as an independent video. On the next live tomorrow, if we could stretch a couple hours into it. I mean, I go bat to I go holy innings, I go stand up and bat, and we could do work for about a good couple hours tomorrow. I'm thinking about the whole after lunch. Right? Think I'm making a clips channel. Yeah, I can make a clip. You can make one. Yeah. Nothing wrong with that. Nothing wrong with that at all. You can go ahead and make the clips channel. Alright, so let me bat out the quotient rule. Let me bat out some differentiation of trigs. And I do not believe differentiation of E is on the syllabus, so I wouldn't show it. Meaning lessons I will show it, Ismail. But differentiation of E is not. I don't think it's on the syllabus. We go check. Alright, next is the quotient rule. Similar to the product rule, the quotient rule will just be y is f of x over g of x. For example, y is equal to x plus 2 over 3x minus 5. Y is equal to 4x squared minus 6x to the power of 7 over x plus 3 and 2x minus 4 cubed over x squared plus 1 squared. Yeah, it is on the pure syllabus for sure. Now, instead of saying is of the form y is equal to uv, it will now be is of the form y is equal to u over v, where u will be my numerator, and just like before, I differentiate it. And v is my denominator, and just like before, I differentiate that as well. Now comes the new rule for the quotient rule. Similar to the product, I start with v du dx, and I have u dv dx. But instead of a plus, I have a minus in between, and I am going to divide the whole thing by v squared. And that is the quotient rule. V du dx minus u dv dx all over v squared. Do expand nothing. Expressing it in its simplest form, I'll multiply the denominator, 3x minus 5 minus 3x minus 6. Alright, I could see something like this coming for your exam. 3x minus 5 squared. 3x minus 3x is 0, minus 5 minus 6 is minus 11 over 3x minus 5 squared. Next is of the form y is equal to u over v, where u is 4x squared minus 6x to the power of 7. And remember, I have a chain inside of a quotient. I am allowed to use the shortcut. Du dx is equal to 7 into 4x squared minus 6x to the power 6 multiplied by the differential of the bracket, which becomes 8x minus 6. And v is equal to x plus 3 dv dx is 1. Divide dx. If I remember correctly, v comes first, followed by du dx. Because his quotient rule is a minus, u followed by dv dx all over v squared. Quotient. This becomes v du dx 7 into 4x squared minus 6x to the power 6 into 8x minus 6. One is never going to come this complicated. Minus u 4x squared minus 6x to the power 7 multiplied by 1 all over v squared, which is x plus 3 squared. Now I am going to factorize it. My common factor here is 4x squared minus 6x to the power of 6 into x 7 into x plus 3 into 8x minus 6, take away 4x squared minus 6x. You can leave it like this. For those who understand it, you can go ahead and leave it like this all over x plus 3 squared. Now, I want you guys to take until 9:57 to finish this third one. A question like this could possibly come for exams, so organize yourself and do that one for me. I'll be right back. all year. Reach back. So, let me give this one a little tackle. Badam bam. Badam bam. Is of the form y is equal to u over v, where u is equal to 2x minus 4 cubed and du dx is equal to 3 into 2x minus 4 squared multiplied by 2, and v is x squared plus 1 squared, and dv dx is equal to 2 into x squared plus 1 to the power 1 multiplied by 2x. You can leave it like that. Nothing wrong leaving it like that. dy dx is v du dx minus u dv dx all over v squared, and this is the quotient rule. V x squared plus 1 squared du dx, I could multiply the 3 by the 2, 6 into 2x minus 4 squared minus u 2x minus 4 cubed into, I can multiply the 2 by the 2x and get 4x into x squared plus 1 all over, oh shit, still on the pink screen, my bad, lovely, all over v squared, which is x squared plus 1 squared. Lovely. I gonna factorize it, or I could leave it like this. I gonna factorize it. X squared plus 1 into 2x minus 4 squared, 6 into x squared plus 1 minus 2x minus 4 minus 4x into 2x minus 4. Nah, me tired. Apex how I play, over x squared plus 1 squared. And you can leave it like that. Hababagu wagwan. Was you wood? Hababagu. Tamola, all look good on that? Is you all a okie dokie on quotient rule, product rule, chain rule, regular differentiation? Yes or no? I'm giving a little time, because remember, it is take a while to my voice to reach earlier, another to reach back to me. So it might have a little minute or 30 seconds of just awkward silence. Yes, it will. My bad. I forgot about v squared. Thank you very much, Josiah. V squared squared to the power of 4. All right, thank you very, very much, dear Josiah. And as simple as I forgot it out, you all forget it out as well. No, Quill. A few good hours of procrastinating, you have work to do. If it's one thing I learned, fellas and ladies who are watching the stream, when you all studying, dedicate the time to study. It pays off. I real procrastinate when I was in early position, and I had to real fight up when it comes to furthering my education. Don't go through that. If you know you have a work to do, go and do the people work. If you have art maths to do, go and do some art maths. Nothing wrong if you could probably have your YouTube playing alongside it, but when you're studying, study. Do your thing. All right? Do your thing. All you big, that has sense, all you responsible, all you should be able to buckle down, do all your thing. If I could do it, all I could do it. So please, ladies and gents, don't be procrastinating. Quill, talking to you. Don't be procrastinating. But I go and stream Apex afterwards if you want to come. Let me just see if them boys go jump on. Because Apex is a team playing game. Right, if they come in, they come in. Alright, so let me jump into the differentiation of strings. Now, when we differentiate in strings, I have a channel for gaming, but I don't post nothing on it. When it comes to strings, it super easy, real easy. I will link it in the chat just now. It's real easy. If I have y is equal to sine x, traditionally, dy dx is cosine of x. That is the transition from sine x to cosine x. If y is equal to cosine x, dy dx is equal to negative sine of x. Now this gives the false impression that the differential of sine of x is cosine of x. So from the time somebody get a question and it says y is equal to sine 2x, students just go and say, well, you know, dy dx could be cosine of 2x. This is wrong. So what I do, I generalize the trigonometric function first. So if y is equal to sine of ax plus b, dy dx states the sine changes to cosine, the angle remains the same, and we multiply by the differential. ddx means differentiate the angle. For example, if y is equal to, like we had just now, sine of 2x, dy dx states sine changes to cosine, and I'm multiplying by the differential of the angle. When I differentiate 2x, I get 2, and you just put it in front. Traditionally, we just put it in front. The same thing applies for cosine of x, ax plus b. But instead of having sine just going to cosine, cosine goes to negative sine. So it's minus sine ax plus b multiplied by the differential of ax plus b. For example, y is equal to, let's say, cosine of x squared plus 4x dy dx. The cosine changes to negative sign, x squared minus 4x, and we multiply by the differential of the brackets, but you can put that in front. Now, because it have a negative sign in front of the sign, in front of the differential here, because it have a negative sign, what you can do for the while, omit it, put the differential, which is 2x plus 4, and then put the minus sign in front of that. Make life easy. Let me do an next example to make life easy. Y is equal to cosine of 3x minus 4x squared. Well, brother man, dy dx, differentiate the angle first. 3 minus 8x. Put your minus sign in front of it because it changes the sign. 3x minus 4x squared. Let me do our next one on sine. Sine real easy. Sine of 16x squared plus x to the power of 3. Well, brother man, dy dx is equal to, differentiate the angle, 32x plus 3x squared. Sine changes to cosine and the angle remains the same. Easy peasy, lemon squeezy. Or let's talk to man. Where's the scene? Any questions? Any questions? Feel free to ask. Feel free to put any comments or any chat. What all you want tomorrow. Tomorrow my aim is to touch on the integration, jump into the kinematics, finish kinematics in about an hour, do logs first and foremost, then probability and statistics, which are going to take a while, then APs and GPs. The Trigs video is on the channel already, go and watch it. I have solutions for up to last year, I think, on the channel already. Go and watch it. What else? What else all I want? All I had to tell me. What else does the people want? I here to serve the people. Hey, you know, I didn't watch the broad topics. Oh shit. I don't know. I didn't watch the broad topics. Hard luck there. If log's not on the broad topics, be safe. So Josiah said he need work on kinematics. Alright, say less. I have all the cover on kinematics. Alright, so tomorrow I have some things planned in the morning time. So preferably a little after lunch. A little bit after lunch, we will start the stream. The people want a ease up. Not before exams, Adele. Come on. Not before exams. If I could touch on coordinate geometry, there are videos on introduction to coordinate geometry with respect to straight lines on the channel. Go and watch them. One of the video got deleted by mistake. My fault. I will have to fill in that gap for that one video, but you could go and watch the videos to get a little background on it, and I'll continue it because applications of differentiation is in kinematics and also in coordinate geometry. All right, so for all those who are here tonight, thanks for coming out. Share the video to as much people as I could. We'll look up differentiation for sure tonight. At least everything we need to know on basic differentiation. Tomorrow is a little thing on integration and one application of calculus, APs and GPs, probs and statistics, and we'll do some coordinate geometry for Josiah. We'll do a little bit of coordinate geometry for you. Monday night, yeah, the night, after 6, I'll say Monday night I'll start streaming about 7:15, and we could probably go until 10, 11 o'clock. We will tackle past paper questions, paper 2 past paper questions. Tuesday, once I get the paper, we do the paper Tuesday night, and we'll start preparing for paper 1. So again, thanks for everybody for coming out. Where I streaming on Twitch. Twitch is the gaming channel. Oh, alright, this is the YouTube gaming channel in the chat. So you could probably go there and hit a subscribe, I guess. I just hardly put up things here. That's some real old videos here. I just hardly put up things here. I've been meaning to get around it, but it's the time. It's just the time. So yet again, thank you guys for coming out. I really do appreciate each and every one of you guys. My goal is to make it on the YouTube. You know, do you follow me on Twitch? Nah, man. I'll link the channel in the description and in the chat. Sorry. Alright guys, again, thanks everybody for coming out. I really appreciate it. I appreciate the feedback as well. Feedback is always a good thing, right? Always a good thing. So keep studying, watch over the live. You all can go through the past papers on your own and see how easy the differentiation questions are. Just the plain differentiation. Forget the applications for now. Differentiation questions are super easy. They'll be similar to lower tier of what we did today. And yeah, good luck with the rest of the studies for the rest of the night, guys. Burn that midnight oil for all subjects, and I will see you guys tomorrow.
I'm taking the world, you'll see. They'll be calling.